Thank you. Yeah, good morning, everyone. Thank you very much for having me. Can you hear me in the last rows? Okay, just nod. Okay, great. Thank you very much. Yeah, welcome to the DevOps talk, and I'm telling you why DevOps is saving your code from the apocalypse. But before we start, maybe a few words about this guy in front of you. So, hi, I'm Patrick. I also graduated here in the Frankfurt University of Applied Sciences, like all of you will, of course. I'm really sure about that. It's a long time ago. I did that. Now I'm a full-stack web developer, and I'm enjoying the industry since 2011 now. And I started in the games industry. Anyone likes to play video games here? Just maybe some? Come on, guys, it's more. I'm sure about that. Okay. Can you imagine making games later when you graduated? No? Okay. Why not? Well, yeah, making games is hard, that's true. Well, anyways, you were in the Java lecture. Do you know the game Minecraft, for instance? Yeah, it was made in Java, so maybe that's an option for you later to make games in Java. But anyways, I made games for the company Limbic Entertainment. These are the guys who made Heroes, Might and Magic and Tropico 6, among others. But after that, I went indie, made my own game for Steam, Super Snowfight. You can still get it, by the way. Presented it at the Gamescom. And then I had to switch industries. I joined a bank. Not the best choice, to be honest. I switched other positions, and now I'm a web developer at this company here, Inside Health. Can you read that? Okay, we have some problems with the beamer. Anyways, Inside Health is the name of the company, and you can see all the buzzwords here. These are the topics we are covering at this company. So we are in the pharmaceutical industry. Big data is a buzzword we are covering a lot. So if you're interested in that, maybe you want to have a look. Meaning, what are we doing? We do market research. So we buy data, pharmaceutical data, process the data, and then sell it again with the help of artificial intelligence, machine learning. You would build the web applications there if you're working there. They are made as a software as a service. And of course, DevOps is a topic in this company. So we're implementing the practices of DevOps. If you're interested in an internship or maybe a working student position, just let me know or go to the website of Inside Health. Okay, now enough about that. Let's get to DevOps. There's not one perfect definition of DevOps, but I found this quote on Wikipedia, so let me read that for you. DevOps is a set of practices that combines software development, that would be the dev part of DevOps, and information technology operations, ops, which is intended to reduce the time between committing a change to a system and the change being placed into normal production while ensuring high quality. Now, what does that mean? It means, in essence, when you're now working on a project, maybe you have some side project, I mean, you're students, you're interested in this stuff, so maybe you should do that. You have a system for yourself. You're working on your code, and you want to compile your application and then maybe put this on a server or on another machine, something like that. And at this moment, chances are you're doing this manually. So you have to compile the app by yourself, then you go to the folder where the for instance, in Windows, the DLL files are, and then you have to transfer everything. Or when you're building a web application, then you have to put it on a server by yourself. DevOps can help you do that totally automatic. So you have no manual steps with that. So if you are doing any change to your code, you want to place that into production automatically, really fast. That's why reducing the time. And also while ensuring high quality. This means there are practices to make sure that the quality is still the same and that you won't get any bugs that might crash your app. That's what DevOps is all about, but of course we will go deeper into that. But before I start with the practices, I want to tell you how you might feel if you implement DevOps or if you don't implement it, and maybe also motivate you. So I've been there when you're not implementing DevOps at all. There are companies that don't want to know anything about DevOps. I hope this changes in the future. But if you have these manual steps and if you're working on a team, you can really get into trouble having no DevOps practices. And in the end, you might end up looking like this. No DevOps at all. You're really shocked. You have to do lots of stuff by yourself, and it's not really easy. The goal is not to look like that cat, but maybe implement a few of the DevOps practices, and then you might work a bit more relaxed. Maybe you can also grab a cup of coffee and just enjoy life as a developer because things are getting easier. Now, the dream for everyone is that DevOps is doing everything for you totally automatic. And in this case, you can just chill at the beach, but that's really a DevOps utopia. We are not there yet, so the goal should really be this image. All right. Now, the theory of every software development life cycle, at least in my experience, is you want to turn coffee or any other kind of hot beverage into profit, or for you guys, into good grades. Now, the interesting part is this arrow in between. What is happening from coffee to profit or to good grades? And at this moment, for you guys, maybe this is magic. But I hope after the lecture, this is not magic for you anymore. Okay. So, DevOps. As you can see here, it is not a process or a straight line from A to Z. It is a recurring process. We have 6 phases. You might see different definitions or different phases in the internet about that, but I think this is a pretty good example. Can you read that even in the last rows? Okay. We have 6 stages and 1 stage that is surrounding every other phase here. We start with planning on the top left. Well, when you're getting a project by your professor, any tasks, you want to plan them. You want to see, okay, what do we have to do? What is any team member doing in this project? After that, you really get to work with the building phase. So you would say you build your software, you build your application, but it's not only about implementing features and your software, it's also about compiling your app, and as I already said, deploying it in the end to a server. And this is where we come then to the continuous integration phase that helps you doing exactly that, putting your software into production, and in the end then we are in the deploying phase. This is actually all that covers the dev part of DevOps, and then we're getting to the ops part, which is operate and feedback. And with feedback, then we go back to planning, and all this again is surrounded by communication. Okay, and here you can see some of the examples of tools that might help you doing exactly that. So you can see, maybe you heard some of them already. For building, there are things like GitHub. For planning, you have Google Drive and all other stuff. I will show you some of the tools later on. Okay, and then the benefits. Why would you even care? First thing is, of course, no or less code mess. You would have less bugs, maybe. Your code would look better, especially when you're working in a team and not by yourself. Faster time to market, that's especially interesting for companies, of course. Time is money. So with DevOps, you can put your code changes faster to production. Early issue detection simply means that you have something like automated tests, so you can see the bugs in your code earlier. And last not least, fun and chill. It's more fun to write code. Okay, now the surrounding phase, communication. In my opinion, the most important one. When you're working in a team, you have to communicate all the time. You have to talk to your team members. When you're a one-man army, maybe you also have to talk to yourself. So this is why communication is really, really important, especially when you have a project like you guys will have in this semester. You might not be at the same place every single time. We have an office, but sometimes people are in the home office or they are at somewhere else, visiting the client or anybody, but still we have to communicate. We have to have the option to ask questions. What do we have to do here? We have issues here, and that's why you need a tool like Slack. Now, by the way, I'm not paid to say this. It's the same with all the other tools I'm presenting here, but in my experience, I'm using Slack for 3 years now, prox, and this is just the best tool to do that. It's at least better than WhatsApp groups or anything like that, or emails. So what is Slack? In essence, you can see it here. It's simply a chat in essence, but You have more options with Slack. For instance, you can not only create your own workspace, invite team members here, and also create other channels, chat privately, but you can also do stuff like file transfer, video calls, things that might be interesting for you. So you don't need other tools like Skype. For example, for the video calls, you can also use Slack, and you can start for free. So maybe, I forgot to tell you, if you want, you can make some notes, of course, but I will show you at the end of the lecture how to get the slides in form of an online course, but you will get the slides for free, so don't worry about that. So Slack. Another great part about Slack is the DevOps integrations, meaning when something happens in your whole DevOps project, then you can send messages and notifications to Slack, but we will see that. So Slack, write that down. Okay, then, the first real phase of DevOps is planning. Did you already have IT project management in your studies? No? Okay. Have you ever heard of the waterfall model? Yeah, some. Okay. Now, in the past, and maybe still today, people are using the waterfall model to plan their projects. And it looks like that on the left. You have one phase, and this phase has to be finished before you move to the other one. That's why it's called waterfall. So the customer comes to you, and he says, I want to have this and that software. I want this as a web application. You write your concept, you write your document, and only when this document is finished, you then go to the next phase, design, and then implementation, and so on. It's not really practical to do it like that in the real world because there are change requests. They will come. The customer usually doesn't know what he really wants in the end. And what are you going to tell the customer? The stuff it's done. You have to pay another fortune for another project. Bet you won't have this customer again. So waterfall model is not the best idea. Better is the spiral model. And as you can see, it's all about iterations. It's again a recurring process, so you have similar phases like requirements and design, implementation, and so on, but you do this in iterations. You start with requirements, and then you go to design, but maybe you don't need the complete concept, the complete finished document. You just have one feature you want to document, and then you switch to design, and so on. And from that, from the spiral model, another software development let's say process practice developed, and this is the Agile software development. Heard of that? Agile, yeah? Okay, I see nodding faces, that's good. That's from Wikipedia. Let's focus on this text here. So what's Agile software development? It advocates adaptive planning, evolutionary development, early delivery, and continual improvement, and it encourages rapid and flexible responses to change. So flexible is the most important word here, in my opinion. You really want to have the option to change things fast, and that's why you are working in iterations. And from that, software development frameworks were developed, including Scrum and Kanban. Have you heard of Scrum? Scrum, anybody? Yeah? Okay, nice. That's good, because Scrum is the software development framework that software companies are using nowadays primarily. And this is, in essence, the whole concept of Scrum. I will go over that real quick. So what do you have, especially for your project in the semester? You have a product backlog. So your professor standing here is telling you what you have to do. Then you want to create, out of these requirements, you want to create some tasks, and you put them into the product backlog. This is everything you have to do. This is everything the software should have in the end. Again, this is given to you by your stakeholders, your customer, your professor, or the so-called product owner. This is the guy in your team maybe who decides, okay, we need this task, guys. We can leave that, but that's everything you need. After that, you go to the sprint planning, and the sprint is the iteration. The similar thing you saw in the spiral model is also here. In Scrum, it's a sprint, and this usually takes 1 week or 2 weeks maybe, but it shouldn't take longer. in the sprint planning, this is a meeting with your whole team, with the product owner maybe, and this meeting usually takes a day or even longer. And in this meeting, you decide what you want to do in the next sprint. So when you're working on your project this semester, maybe you make a video call with Slack with all your team members and then decide, okay, guys, we have this mountain of tasks, but let's focus just on these two. And in this case, you would put these tasks to your sprint backlog. So these are the tasks you want to finish in the next week or the next 2 weeks maybe. And it's the nice thing about that is you don't have any kind of project manager who tells you what to do. You as the developer decide, okay, this is what I want to do. I think I can do this in the next week or the next 2 weeks, and you really commit to that. So you decide how long it takes to do it, and you really commit to it. The thing is, if anything happens, it's not really that bad the first time. The second time, maybe, but if you have to estimate how long it takes to finish a certain task, and you don't really know. Actually, you never know how long it really takes, but in theory, your boss wants you to know, so you just estimate it. Anyways, so the sprint backlog, and from the sprint backlog, then you start working on your project. You have your Scrum team. I don't know how big your teams will be. 5, 4, 4. Okay, 4. Yeah, that's great. A great number. And in the sprint, then you have the so-called daily scrums. So you might think every day a meeting. This really sucks, but not the daily scrum, because the idea behind the daily scrum is that every team member just talks a minute max. So you have 4 team members, 4 minutes, and the meeting is done, in theory again. With this daily scrum, you have your Scrum Master, the so-called Scrum Master, who decides what you guys may want to do today, and every single team member is telling in this daily scrum what he or she did yesterday, what he or she is doing today, and if there are any problems. If there are problems and you need to go into detail, you do that after the daily scrum. So then you go to your Scrum Master, for instance, and try to think about how you can solve any kind of problems, what team member can help you with that. But this way you get much more organized and, in particular, very productive. After your sprint, you have the sprint review, where maybe, I don't know if you will do that in the semester, but usually you're talking to your customer again. Because after a sprint, you want to do some kind of user acceptance tests, which means your customer is looking at the feature and he says, okay, this is great, this is exactly what I wanted, or he tells you that's not what we were talking about, so you have to do it again. So maybe you have the option to talk to your professor and just asking him after a week or two, are we on the right track here, or do we have to change something? Another great part about this recurring process of the Agile software development theory. Okay, and then in the end, the sprint retrospective, this means you come together as a team again and just talk about the things that went well and the things that went not so great, so you can do it better in the next sprint. Okay, that's Scrum in general. Any questions about that? By the way, you can ask me anything if you want. No? Okay. Another Agile framework is Kanban. Ever heard of Kanban? No? Okay, great. So Kanban originally came from Toyota in the manufacturing industry. One engineer of Toyota said, okay, we need some kind of system for just-in-time manufacturing. How can we do that? And this evolved then into this Kanban method with the Kanban board you can see here. The thing is, you can use Scrum and Kanban together. When you're in your sprint, you can, bless you, you can use Kanban for your specific tasks. Now, you see you have several columns here. On the left, it's called resources, but you could also say, okay, this is our backlog, for instance, or you use the to-do column for your sprint backlog, and there you see all the tasks that you want to do in the sprint. And you can use a tool like Trello here to assign it to team members, to give them some labels, categories, anything like that. If a team member then is working on a certain task, you just drag and drop it into the doing column, and then you move on to the done column if this task is finished. Highly recommended because it's great to just organize your work for yourself. How would that look like? With Trello, for instance, again, it's available for free. You start with a clean board, then you create your lists, a to-do list, doing and done. Then you write all your tasks there. And as I already said, what you can do after that, for every single task, you can add a description, you can assign team members, even checklists, comments, and so on. And in the end, you move that to the done column. Okay, that's in essence the planning phase. Any questions about that? Okay, great. I see we already have 40 minutes. We still have time, right? Okay. Okay, building, maybe the more interesting part. I cannot tell you what IDE you want to use. I mean, you're Java developers here, so maybe Eclipse on the bottom left is your IDE to use. I love Visual Studio Code. This one here, I'm working on a project with C#, JavaScript, TypeScript, but you could also use Visual Studio Code for Java and Python maybe with some extensions. So maybe you want to have a look into Visual Studio Code. Great IDE. But that's not what I want to talk to you here is, what I want to tell you here is not what IDE you want to use, but how you should build your project. And the magic words here are source control. Do you know what source control is? Ever heard of Subversion maybe? CVS? Okay. Now, source control means tracking and managing changes to code. And, well, we get to the details later. But the best source control system today is Git. Ever heard of Git? Some of you. Do you know who developed Git? Who made this? Yes, please? Correct. Linus Torvalds. Great. Do you know what else he did? His first big project. Yes? Correct. Perfect. So he says his first big project was Linux, and his second big project was Git, and he just needed this to organize Linux. So crazy guy, but he really knows his stuff. Git was developed by Linus Torvalds, and this is how Git might look like. This is a Git client, and what Git does is you have a kind of a repository where all your code is stored. So again, when in the past or when you have your side projects and you have your code on your own hard disk on your machine, and I don't know, you want to try something new, what do? Maybe you copy and paste your files into another folder, and then you have to go back again. This is history with a source control system like Git. You have a repository where you commit and push your code, and the great thing is you can go back again. What you see here, this is pointing out, great. So here you see the whole repository in essence, and these are the single commits you can see here, the whole history, and especially when you're working on a team, you really see what your team members are doing, and if they work, for instance, on the same file you are working on, you might have some trouble when you're not using source control, but in this case, you can just push your code and Git is everything doing for you. It merges your code so you don't have to worry about that. Even if you're working on the same function maybe, then Git will try to merge this. There are other great features about that, like resolving merge conflicts and branches. We will talk about them in a second here. First thing, merge conflicts. So again, I was telling you when you and your coworker or your team member is working on the same file, the same feature, or the same bug fix, whatever, you want to merge your code. And it could happen that you did not use communication properly, and then you get a merge conflict. In this case, it just means that maybe the same line of code was edited, it was changed, and Git in this case doesn't really know, okay, what should I use here? What is the correct version? Is it theirs? Is it ours? In this case, you will get something like that. Every kind of Git client is able to resolve merge conflicts or give you the proper screen to resolve the merge conflicts. And if you're not able to decide, okay, it's theirs or it's ours, you have to edit manually, then you can do that at the bottom there. There's an editor where you can resolve this conflict then. Git clients, there are enough Git clients available. These are just some of them. You can use your own IDE. I think Eclipse can do that too. And Visual Studio, of course, but you can also use other kinds of clients like Tortoise, Git Source Tree, Git Kraken, Fork, and so on. Or if you're more Linux guy, maybe you can also use the Git Bash, the terminal, or the command prompt, just depending on your operating system. So you should really have a look into Git before it can work. Of course, you have to download it. This is the URL, or just Google it. It's available for every operating system. So make this happen, guys. Git is really, really great. Okay. Now another feature of source control are branches. You see the lines here. These are, in essence, different kinds of branches. Thing is, again, I said when you're working on your own, you have files on your hard disk, and then you want to try something else. Then you would copy and paste your files, and then look if it works on your copied folder. And what do you do after that? You have to copy or paste again back. Not with Git, of course. What you can do is you can create a so-called feature branch. And with that, you see the lines that are, what is it, green, I think. The violet or blue line is the so-called master branch. So this is the main code base you have. And if you create a feature branch, then, for instance, the green line here, you have that other code base. And in this code base, you can do whatever you want. You won't destroy the main code base, so everything is still working. And only when you are sure that your changes are working, you can then merge back your feature branch to the master branch so that everything is fine again. A great example for that are these screens here. Do you know who Sonic is? Sonic the Hedgehog. Some gamers here. Okay, great. This is taken from the trailer of the Sonic movie that comes out in February, I think. Now, the first version here is a great example. Paramount, the publisher of this movie, released a trailer of the Sonic movie, and the result was a shitstorm in the community. Everybody hated the Sonic. They wanted to make him more realistic, but that did not really work out. So you could say this was merged directly into the master branch. You're just working on your master branch, you make any changes, you don't test them, you just push them back, and your coworkers hate you for that. This is the result. It's better to use feature branches, because then the second image, you can see, okay, this guy created a feature branch, he tested his own changes, and only when this was reviewed and, let's say squashed, but you don't have to worry about squashed, let's just say you created this branch, tested everything, and then merged it back. It looks much better, like the Sonic down there. Okay, so far any questions about source control? Okay. One tiny thing I want to talk to you about are containers. Let me just read that. Containers like Docker can package an application and its dependencies in a virtual container that can run on any Linux server. This helps provide flexibility and portability, enabling the application to be run in various locations, whether on-premise, in a public cloud, or in a private cloud. Docker containers are able to run within a single Linux instance, avoiding the overhead of starting and maintaining virtual machines. So why I am telling you this, the thing with containers is, maybe at this moment, what you have to do is you need an own server and another machine if you want to test your application. With containers like Docker, what you can do is you can configure a kind of a virtual machine, a tiny little virtual machine like a Linux VM, and when you compile your application, you can then run this container, and the application is running on this container. It's like a fresh system every single time, and you don't need much overhead. You don't need a server, you don't need another machine, no platform services, nothing like that. You just create a Docker container for that. But that just on the side, don't want to go into deep. with that topic. Okay, continuous integration. We are on the third of 6 phases of DevOps. Again, a great quote here. What is continuous integration? It is the practice of integrating code into a shared repository and building or testing each change automatically as early as possible, usually several times a day. So again, if you're not using any of these practices of DevOps, what you want to do is actually not committing your code or copying and pasting changes several times a day. What you would like to do, because this is a big manual effort, you want to write your code, your team members will write the code, and by the end of the week or even by the end of the month, then you try to merge everything. With continuous integration, though, you can automate this process. So what you can do is you have your source control repository with Git, you commit your code several times a day, you should at least, by the end of the day or by the end of every single commit, continuous integration is all the magic for you. So you don't have to merge your code, you don't have to push it to your server or anything else. That's what continuous integration is all about. Testing was also mentioned here. You see it again here in this process. Just in short, that's I think a graphic you can really try to remember. You build your application, and then you want to test it. I'm telling you something about tests in a second. And then in the end, you want to deploy this. And continuous integration is everything for you. A short excursion about automated tests. Automated tests. The mostly known tests are unit tests and integration tests. Ever heard of unit tests, maybe? Okay, it's quite early in the semester. So, unit tests are, what they want to do is you want to test your single units in your application. So imagine you're writing a calculator, for instance. Then you want to test if the subtraction is working. So you write a test just for subtracting numbers. Then you write a test for the addition, and so on. These are unit tests. You test every single function of your application. Integration tests then test the whole application. So you want to write a test where you subtract and add some numbers, for instance. It's more suitable for web development because then you have your backend, you have your web service, for instance. You write tests for your web service. But then you also have to test it in combination with the UI, with the front end, because if you click a button and nothing happens, then you can have the best backend in the world. Nothing happens, really. So you need integration tests for that. The third thing here is the test-driven development approach. It's not really often used in the industry, although it's a great concept. With test-driven development, what they mean by that is, for instance, your project now that we will get, I don't know, next week maybe. Okay. What you want to do is, it's more likely that you first try to implement your features, and if you want to use, and if you have the time to write some unit tests, you do that after you implemented the features. With test-driven development, it's the other way around. You first think about the tests. You write your tests, and then you write the implementations for these tests. But it costs a lot of effort and a lot of money, and time, and time is money, and that's why lots of companies don't really do that, because they don't see the benefit in that, because they only see the profit. So in the industry, you will rarely see the test-driven development approach, although it's a really great thing, because in the long run then, you can, whenever you make a change, you can automatically run your tests, and you will see if any bugs are in your application. If you don't have any tests, maybe you won't see the bugs. You get the bugs in your app, and the customer will see it, and in the end, you lose maybe some customers. So it's in the long run maybe better to do test-driven development. But at least maybe try to write some unit tests. Just start with that. If you're not using unit tests together with integration tests, something like that might happen. You can see that the sliding door and the swing shopping gate, they are working perfectly on their own, but together, I think this is not really the idea behind these two. Okay. Automated tests. Again, for automated tests and unit tests in particular, there are lots of different frameworks. I used Visual Studio a lot. I'm really in the Microsoft world here. And this is the Microsoft testing framework. How does this look like? You can see on the left here are all the tests. One failed. You see the past tests, and you see the tests that have not been run at all. And on the right side, you then see all the details about this failing test. So maybe it's the test itself that was written wrong, or it is really your application. So that's pretty nice. Before you push anything, you just run your test and see, okay, did I do anything wrong or went everything right? For Java, for you guys, if you're using Eclipse, JUnit might be a testing framework you want to have a look at. In essence, it's the same. You see the tests on the right side, and on the left side, and on the right side, you see that to write these tests, you have some annotations. You know about annotations now, right? Yeah, okay, professor's nodding. Okay, great. So this is how you write your tests, in essence. I cannot go into more details, of course, because DevOps is a great topic. So continuous integration, that's it. There are, again, lots of tools to do this. You can have a look into Jenkins, Hudson, Bitbucket, GitLab, Azure DevOps. In my experience, Jenkins, for instance, or Hudson, I think Hudson is the one that Java uses a lot. Great tools, but they are mainly used for continuous integration alone, and you can extend it with plugins. So let's say you also want to have, I don't know, deployment, or also use a repository with Hudson or Jenkins, then you have to put some work into it to set this up. In my experience, and what we are using at the inside, actually, is GitLab, much better. Similar things are Bitbucket or even Microsoft Azure DevOps. You see the DevOps term even in the name. This is more than just continuous integration. You get lots and lots of stuff with it. For instance, you have your repositories, you have issue tracking, you have notifications, and so on. So lots of stuff. I will show you GitLab in detail after some slides. That's what you have to think about. Maybe use something like continuous integration alone, Jenkins or Hudson, or maybe a tool that has all the DevOps stuff in it. So how would you make continuous integration work? With GitLab, for instance, and it's similar with Bitbucket, for instance, or any other service like that, you would need a configurations file first. In this case, it's a GitLab CI YAML file. There are also TOML files for other services, and you put that file into your root directory of your repository. So this is just an example for a root directory of our applications, and you see the file is put there. And then this file is nothing else than just a script file, or a batch script, you could say. On the top, I think it's hard to read now in the last row, but anyways, in the top you see a configurations file for our backend service written in .NET Core, and on the bottom you see a configurations file for an Angular front end. And what you do, you can define several stages, like the deploy stage, and then you write what should really happen in this deploy stage. Here you can see the .NET build command, and then a publish command for the debug and the release version, and we're using the Internet Information Services on a Windows server, so then you see commands to deploy it to the server. At the bottom, you see something like the npm install to install dependencies for your front-end application, then build the Angular app, and so on. If you would use tests, you would also have the commands for your tests right there. So you would see if everything is correct, and then the deployment. So really the graphic, build everything, compile everything, then the testing, and then the deployment. This is done in this script. And in essence, these are just the commands you would use on your local machine when you try to build your application. Okay, then the great thing. I was talking about integration into other tools. Now together with Slack, for instance, if your script is running and everything went right, then you see something like that. This screenshot here is from work, so I have made a change, and Slack is then telling everyone in the team that that I had pushed a change to the master branch directly, not the way you should do it. And then you can also see the pipeline. So this is in essence the building process of continuous integration, which tells you then that everything went right. So this one passed here, others might have failed. Another great thing about Slack is you see all the channels here on the left side. Really important, the laser tag channel on the bottom. Yeah. Okay, and then what I can do is I can click on compare changes or on the number of the pipeline here, and then see, well, the actual change. So here you can see what I did in this little change. What did I do here? You should know that. So the green line is the addition. I added something to an if statement. Okay. You see the changes, and again, this is really small now, but in essence, this is the pipeline process, the build process, and in the end, it says job succeeded. Okay, so this is continuous integration in a nutshell. We can even go a bit further with continuous delivery and deployment. What you do then is, as it states here, continuous delivery adds that the software can be released to production at any time, often by automatically pushing changes to a staging system, and with continuous deployment, it goes even further and pushes changes to production automatically. So this means usually with continuous integration, you would just deploy your app to a test server, for instance, a staging system where then the quality assurance in your company can test the application, and only after them saying everything is okay, we push it manually maybe to the production server that the client uses. In this case, you could really say, I trust my code and the tests and everything else, and I push it directly into production, and the customer is using my change after a few minutes. And with that, we are getting really to the beach someday, maybe. Okay, questions about continuous integration so far? Okay. So deployment. We are at the 4th or 6th stages and maybe the last stage of the development part. With deployment, what I want to tell you here is that you don't need your own server every time when you're working on an application or a web app, a software, whatever. You can use some kinds of services like these here: Microsoft Azure, Amazon Web Services, Google Cloud Platform. These are complete DevOps solutions. The great thing about that is you can say, hey, I need a database maybe. So you just grab a database from these services. Then you say, I need this processor, I want that memory, I want this hard disk, and so on. So you can really pick the hardware you want and the services you want with all these services, and you don't have to rent a virtual machine or a dedicated server by any provider. So that's maybe why you want to have a look into that. Microsoft Azure, for instance, you can see it here. There are ways to test and deploy your apps. Doesn't have to be enterprise apps. You can also create custom mobile experiences for your mobile apps. And what's also very nice, you get insights from your data. So otherwise, if you would have your own server, then you would have to add some more tools to track your data maybe. But be careful, we're in Germany, so you really you're not allowed to track everything. But still, people do it, and with Azure, it's really easy to do it. Okay. And the great thing about that is you can use it for free for the first 12 months. So I don't know what your project will look like, but if you are developing a web application maybe, or a mobile app, or maybe you can turn it into a mobile app, then in this case, you can try out Azure or also Amazon Web Services or Google Cloud Platform. Amazon Web Services looks quite similar. They have different kinds of free tiers, as you can see here. They have services that are always free, services that are free for 12 months, and other kinds of services where you get a trial time like 30 days or something like that. And with Google Cloud, they have kind of a different approach. They give you $300 for free, and you can do anything you want with that and try anything out. And just as a side note, you don't have to do it for your project. If you're interested in software development and you have your side projects, just use these things. Great companies are using it as well. And the great thing about the Google Cloud Platform is you get free access to their services and APIs like Firebase or the Google Maps APIs. Otherwise, it would cost a lot of money to do that. And what I think is really nice is that they don't auto-charge you after your free trial ends. So you don't have to enter your credit card information or anything. You can just play around, and when the time's up, you have to manually upgrade your account. Okay. Now, Bitbucket and GitLab is then the next slide, are a bit different. Could be the case that you still need your own server for that. But as you can see here, it's a typical pricing model. You have a free pricing plan that you can start with, and you already get, as you can see it, the CI and the CD thing right here. It's in the free pricing plan, so you can just try this out. You have also Trello integration, what I think is really great. And with GitLab, it's almost the same. You have a free pricing plan here. You get the continuous integration part. You already get issue tracking, integrations to Trello and Slack and everything. And yeah, you can really try this out. So in the end, it's really up to you how you want to develop your application. You can start with Bitbucket or GitLab maybe, because then you really have to try to get the hang of it, and maybe then you switch to the big three from Microsoft, Amazon, or Google. Okay. That's deployment. Now operate. Do you know this movie, by the way? Yes. It's 20 years old, so I really am glad that you know this movie. Okay. Operating. So what is operating all about? We are at the ops part of DevOps, and it's about server monitoring, logging, sending notifications. And again, there are tools for that. This is just a handful of them. Nagios, Loggly, Splunk, Dynatrace. Maybe you want to have a look at this. Nagios, you see, is all about monitoring. You can monitor your Windows server, Linux server, your application, and also log this monitoring. And here you can see the structure of that kind of software. So you have on the left side your machines, your development, your database machine, your application server, and then Nagios comes in between. It is monitoring your servers, and then if anything happens, Nagios is able to send you notifications via email, for instance, SMS, or maybe a push notification nowadays, and also just log this stuff into a database, and then you can access the logging through the browser. Okay, now Dynatrace takes a different approach. What they do, to be honest, I don't have any experience with Dynatrace, but they say that they use the monitoring and the logging data to give you solutions and answers with their AI-powered and machine learning system. Again, also a free version available, so if you're interested in that stuff, maybe have a look. But in my opinion, regarding operating and logging, you can also do it just by yourself. What we do at work most of the time is simply logging the stuff by yourself. So when you write a web service and an exception is thrown, then you just log this into a file or a database. If people are making any web requests, you log that as well. And if anything happens, then we send an email to us. We show an error message on the page, and then we can have a look into that, and we're done, actually. This is everything you really you need, in my opinion. Especially, I think, for your project, maybe this is a nice approach. Just send an email if anything happens. Okay, and that's already operating. We're running out of time a bit. That's why I'm that fast. Any questions about that? Yes, please. Deploy? Well, it's... Let me just have a look. So, deploy actually really means that with you write your software, for instance. Then you want to build it. You compile your application, and then you see it on your local machine. It's working, great. But if you then want to have it out there to the public, and that other people can use it, then you deploy it to a server, for instance, where people then use it. That's it, actually. So in particular for web applications, deployment simply means that your app, your web service, your front end, everything around this is deployed to a server. And that's why I was showing you all these platforms here. You could rent your own dedicated server. Strato, for instance, is a provider for that. And you can deploy it to this server, or you could use some kind of platform like Azure and deploy it there. And then people can access it. Okay? Yes? Yes, of course. You can use it too. You can use. That's why I was showing the platform services like Azure and so on. They have the continuous integration, for instance, and they will also. You can configure them to do the tests. You have to write the tests, of course, but then you can configure your files and anything that these platforms then run the tests, and only when the tests have passed, they deploy your application. Okay? Great. All right. Okay. Operating feedback. The last phase, feedback. Okay. It's about automated status updates, IT service management, customer relationship management, and bug tracking. I really want to focus on bug tracking because I think you don't really need any kind of customer relationship management here. These are some of the tools that are interesting regarding feedback. These are the tools that focus on customer relationship management. Just short, what does customer relationship management mean? You're buying something on Amazon, for instance, and then this purchase is saved in a CRM, like Salesforce. And then if any problems occur, maybe you have a Prime account and your delivery is not there the next day, but in 2 days or something like that. Then you call Amazon and say, hey, this really sucks. I'm paying for the service. Why is it like that? Then all this information, all this communication is stored into this Salesforce account from Amazon. Maybe Amazon has its own customer relationship management tool, I don't know. But that's what customer relationship is all about. They want to satisfy the customer. So they save the whole history of this customer and maybe give you a discount of 10% for Amazon Prime, something like that. And that's in essence what customer relationship is all about. Get more customers, have happy customers, and then you get more profit. But I want to focus on issue tracking, or you can call it bug tracking, and also IT service management. Now, IT service management is a bit bigger, but it's more focused on inner IT departments. So what's issue tracking all about? Of course, if any bugs occur, for instance, you use a service like these here to track these bugs. You write a ticket. This is put into Mantis or Bugzilla, and then the developers can have a look what was happening here. Maybe you add a screenshot, anything like that. And this is the example of Mantis. Again, you can use it for free. And what I like about Mantis here, you can see on the bottom right that you can even check out the bugs of Mantis itself. And this is how this issue tracking software looks like. I hope you can read this. So on the top, you see unassigned tickets, you see resolved tickets at the bottom, and the whole history, the timeline of your bugs or the tickets that you are working on. And if you want to see some more details, you just view the issues, and then you see some more properties like the category of this bug, the severity, how important is it? Is it a crash? Is it just some kind of user interface error, but the app is still running? You see the status, updates, or when it was updated, and a summary of that. Kind of helpful if you want to track bugs. Now, Jira, this is made by the same guys who make Bitbucket. That's why they have the integrations. Jira and Bitbucket work great together. It looks similar, but Jira is more used really as a ticket system. So it's not only about bugs, but also about feature requests, for instance. If a customer comes to you and he or she has a change request, then you put that there as well. And slowly we come full circle here, because with GitLab then you see this looks quite similar to Trello. Like this, you see that you have your Kanban board again. You can add your bugs here, your tickets, and then you use these tickets to get back to the planning phase. And that's it, actually. That's the whole DevOps part. Any questions so far? Okay. So we've come full circle. You see there are lots and lots of tools for all the different phases. In the end, it's up to you. Do you want to use several tools? Do you want to do stuff by yourself? Or do you want to use just one tool and do everything with this tool? Remember the cats here, which is what is your goal, and as you can see here, these are the tools you can use for that. Okay. That's how you get the slides. I created an online course you can access for free, just for you guys, by the way. This is URL. You can write that down. You can contact me on Twitter. There are other ways to contact me as well. And if you're interested in coding, not only Java, maybe you have a look at Udemy. There are some courses also by me. And again, if you're interested in an internship or working student position, maybe just contact me or have a look at the Inside Health website. Okay, if you don't have any questions, thank you very much. That's it.